NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
James Webb will go where no other telescope has gone before.
For centuries, scientists and enthusiasts have gazed into the depths of space, pondering what lies beyond our reach. The James Webb Space Telescope, with its powerful lenses, stands at the forefront of unraveling this puzzle. Recently, it has made groundbreaking announcements that shed light on what lies at the edge of our observable universe. What do these new discoveries by the James Webb Space Telescope mean for our universe? Could this be the end of our exploration of space? Join us as we delve into the latest discovery of the James Webb Telescope could destroy the universe. Theories surrounding the universe. To understand the most recent findings, it's important to understand some context. In the vast space of the cosmos is one of the biggest mysteries that has and is still captivating humanity, starting many centuries ago, the edge of the observable universe. Looking deep into the wonders of space, scientists and enthusiasts alike have pondered what lies beyond our reach. The observable universe encompasses all we can perceive, measure, and study from Earth and through our space-based instruments. Within this observable realm exist stars, galaxies, and celestial wonders beyond imagination, but what lies at the edge of the observable universe? The James Webb Space Telescope holds the key to unveiling this mystery. With its powerful lenses peering deeper into space, it has recently made a groundbreaking announcement of what lies at the edge of the observable universe. However, to fully understand the universe and the observable universe, in simple terms, the observable universe is just a small fraction of the entire universe that we can study and comprehend, while the complete size and shape of the entire universe are unknown, stretching across unimaginable distances, with an estimated diameter of approximately 93 billion light-years. A light-year is a unit of distance that light travels in 1 year, which is about 5.88 trillion miles or 9.46 trillion kilometers. So, the diameter of the observable universe, 93 billion light-years, is an unimaginably vast expanse spanning approximately 546.84 billion trillion miles or 878.58 billion trillion kilometers, showcasing the mind-boggling scale of our cosmic surroundings that's difficult to even comprehend. But why is the universe so vast? The answer lies in the origin of the universe and what is popularly known as the beginning of the universe, the Big Bang. About 13.8 billion years ago, the universe burst into existence in a cataclysmic explosion, setting in motion the cosmic symphony we observe today. Since then, the universe has been expanding relentlessly, driven by mysterious forces such as dark energy. As the cosmos expands, particles come together under the pull of gravity to form masses, giving birth to celestial marvels like stars, galaxies, and planets. Over eons, these structures have evolved, inking out a painting of cosmic beauty and diversity that stretches across the cosmos. But you might wonder, if the universe truly is expanding, then what is it expanding into? This is a misunderstanding of what is meant by the expanding universe. Here's why. In Berlin in 1915, at the height of World War I, Albert Einstein came up with a revolutionary theory of gravity, which supplanted Newton's. In 1916, he applied it to be the biggest source of gravitating mass he knew of, the universe. What Einstein's theory showed was that the universe could not be still but had to be in motion, either expanding or contracting. In fact, in 1929, the American astronomer Edwin Hubble discovered that galaxies were flying away from each other like pieces of cosmic shrapnel in the aftermath of a titanic explosion, like the Big Bang. This, in essence, is what we mean by the expansion of the universe, that the distance between galaxies is growing. Einstein's theory could easily describe a universe that goes on forever and therefore has no edge, or one that curves back on itself like a higher-dimensional version of the surface of a ball. However, despite its vastness, the universe is predominantly empty. To put it into perspective, within our Milky Way galaxy, if we scaled down our entire solar system to the size of a quarter, the nearest star would still be distant by the length of 2 soccer fields. So why can't we see the entire universe? 2 factors explain this. The first reason is that light takes time to travel through space. When we look at distant objects in the universe, we're observing them as they were in the past. The farther away an object is, the longer its light has taken to reach us. So, by observing distant galaxies, we're essentially traveling back in time, unraveling the history of our cosmos. The second reason is the universe's expansion. Imagine dots on the surface of an inflating balloon. As the balloon expands, the dots move away from each other. The same principle applies to the universe, where galaxies are drifting apart as space itself stretches. This expansion causes the light from distant objects to become stretched too, shifting towards longer wavelengths, which we perceive as redshift. Eventually, some objects will move beyond our observational reach as they recede beyond a certain distance. Considering these factors, does the universe actually have an edge? The edge of the universe remains a puzzle, shrouded in speculation and many theories. Some propose that the universe extends infinitely, with no discernible boundary, while others envision a finite cosmos that loops back upon itself like the ball-like shape described in the theory earlier mentioned. Then there's the interesting theory of the multiverse, suggesting that our universe is but one of many, each with its own laws and properties governing it. The James Webb Space Telescope. Having understood the concepts around the edge of the universe by studying different theories, we will now look at the remarkable tool that will potentially shed more light on these theories and answer our many questions, the James Webb Telescope, JWST. Launched in December 2021, this telescope stands as a beacon of human brilliance, put at the forefront of cosmic exploration, representing a massive leap in our quest to unlock the secrets of the universe. Equipped with state-of-the-art instruments, JWST possesses capabilities far beyond its predecessor, the Hubble Space Telescope. The tools possessed by this heavyweight include infrared cameras, spectrographs, and coronagraphs, allowing it to peer through cosmic dust clouds and observe objects with unprecedented clarity. These instruments enable JWST to capture faint signals from the farthest reaches of space, providing astronomers with a window into the universe's distant past. One of JWST's most remarkable features is its ability to observe in the infrared spectrum. Unlike visible light, which can be obscured by cosmic dust and gas, infrared radiation can penetrate these barriers, revealing hidden celestial objects and events. This allows the telescope to observe the formation of stars and galaxies, trace the evolution of cosmic structures, and explore the depths of black holes. And without much surprise, the JWST has made a series of groundbreaking discoveries that have reshaped our understanding of the cosmos since its deployment. From ancient galaxies to black holes, JWST has uncovered a wealth of new phenomena that challenge existing theories and ignite scientific curiosity. Despite all that is expected from the JWST, it still manages to surprise scientists who study its explorations. In a recent study published in the journal Nature, the JWST discovered 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. Researchers were only expecting to find small, newly formed galaxies, but the JWST caught them by surprise. These galaxies are way larger than anyone ever imagined, challenging what we thought we knew about the early cosmos. But that's not all. Scientists also found something mind-boggling. These galaxies are as mature as our 13-billion-year-old Milky Way galaxy. Nobody expected them. They were not supposed to be there. And now, nobody can explain how they had formed. These galaxies are nearly as massive as the Milky Way and full of mature red stars and seem to be dispersed in deep-field images obtained by the James Webb Space Telescope during its early observation campaign, and they are giving astronomers a headache. Such early galaxies are not in themselves surprising. Astronomers expected that the first star clusters sprung up shortly after the universe moved out of the so-called Dark Ages, the first 400 million years of its existence when only a thick fog of hydrogen atoms permeated space. But the galaxies found in the Webb images appeared shockingly big, and the stars in them were too old. The new findings are in conflict with existing ideas of how the universe looked and evolved in its early years and don't match earlier observations made by Webb's less powerful predecessor, the Hubble Space Telescope. These gigantic galaxies, nicknamed universe breakers, have scientists scratching their heads. They defy 99% of the models we had for early galaxies. We used to think galaxies started as small clouds of stars and dust, gradually growing over time. Well, these universe breakers proved us wrong. When the Webb data and high-resolution photos from the telescope became available in July 2022, researchers were blown away. They were taken aback when they saw these galaxies as significant points of light, doubting their interpretation of the data, with scientists speculating that perhaps our understanding of how stars form locally, for example, how many stars form from gas as a function of the mass of the stars, is inapplicable in the early universe. The sudden appearance of these colossal objects surprised everyone. By using spectroscopic techniques to analyze light across different wavelengths, scientists can uncover valuable information about these galaxies, such as their composition, size, and distance from Earth. What's fascinating is that this groundbreaking discovery wasn't even on the top of the list of things scientists hoped to find with the James Webb Telescope. It exceeded all expectations and unfolded much quicker than anticipated. Meanwhile, using the powerful James Webb Space Telescope, an international team of astronomers also made an incredible discovery. They found the oldest and farthest galaxies ever confirmed, when the universe was still in its infancy, taking us back about 325 million years after the Big Bang. To some, this is nothing much of a little red blob with a rather quirky name of JWST 13-0, but this faint smudge, imaged by the James Webb Space Telescope, is a big deal and is the most distant galaxy so far confirmed by gold standard measurement. Putting its age into perspective, if the universe is 13.8 billion years old, it means we are observing this galaxy when the cosmos was only 2% of its current age, which is mind-blowingly young. It means this discovery has basically got us looking directly into a baby universe. Our previous, most distant galaxy was detected by Webb's predecessor telescope, the veteran Hubble Space Observatory. It spied the equally quirkily named JWST. This galaxy was seen to be a little closer to us, at a time when the universe was only 400 million years old. But the big deal here is that the baton has truly now been passed from Hubble to James Webb, from one great telescope to the next great telescope, as scientists seek to trace the earliest epoch of star formation. JWST 13-0 is a high-redshift Lyman-break galaxy discovered by the James Webb Space Telescope during NRChem imaging for the JWST Advanced Deep Extragalactic Survey, JADES, on September 29, 2022. Spectroscopic observations by JWST's NRSpec instrument in October 2022 confirmed the galaxy's redshift of 13.2 to high accuracy, establishing it as the oldest and most distant spectroscopically confirmed galaxy known as of 2022, with a light travel distance of 13.6 billion years. Due to the expansion of the universe, its present proper distance is 33.6 billion light-years. Now, what is redshift and how does it help us determine the age of these ancient galaxies? Well, it turns out that as the universe expands, objects appear to move away from us, causing their light to stretch and shift toward longer, redder wavelengths, a phenomenon known as the Doppler effect. While redshift estimates can be derived from photos taken through various filters, spectroscopy is the preferred method for obtaining precise measurements, as it breaks down the object's light into its constituent wavelengths. The new discoveries focus on 4 galaxies with redshifts greater than 10, meaning they are super far away. The Hubble Space Telescope previously spotted 2 of these galaxies, and their redshifts were confirmed to be 10.38 and 11.58. But the JWST images revealed 2 even more distant galaxies with redshifts of 13.20 and 12.63. Redshift 13.2 indicates a time period roughly 13.6 billion years ago, revealing ancient cosmic history. As we continue to push these boundaries, we remain open-minded, as the universe is a vast and ever-changing place, filled with wonders waiting to be discovered. Through continued collaboration and innovation, we can unlock the secrets of the cosmos and inspire future generations to explore the unknown. Thanks for watching. See you on the other side.